Hello everybody, this is a presentation on analyzing the effects of whisking, egg type, and ingredients on omelet height by Tsuyumi Konishi, Victor Valley, and Ryu Sakaguchi. The significance of this experiment is, first of all, breakfast is the most important meal of the day. Who doesn't love breakfast? Secondly, omelets are a staple in French cuisine, and multiple recipes have suggested that whisking, adding milk, and the careful selection of eggs leads to better, fluffier omelets. And so this is an exploration on what leads to those kind of omelets.
Our explanatory variables were egg type, whisking, ingredient, and order, where our levels were caged and free range, whisk, and no whisk, where for whisking we whisked for 20 seconds, and for no whisk we stirred using a chopstick, and we got rid of any air bubbles. And for ingredient, the levels are water, carbonated water, and milk. And for order, we randomized using Microsoft Excel. Our response variable was the height of the microwave omelet measured in centimeters, and we used a template in order to measure the same 5 points for every omelet that we made, and we took the average of that height as our final measurement.
For our method, we used 3 identical mugs to make the omelet, and first we put in either cage-free or caged egg, just one egg. And then for the second variable, we put 3 tablespoons of either milk, water, or carbonated water inside with the egg, and then we either whisked that mixture or we for 20 seconds, or we didn't whisk, in which case, as we mentioned earlier, we stirred with one chopstick and got rid of air bubbles. And then after we did that, we microwaved the mug for 45 seconds, and then immediately afterwards we measured the omelette height at 5 points using a template as shown, and we took the average of those.
The model assumption for our three-way ANOVA is that the data came from an SRS. The data is distributed normally. There are no extreme outliers or skewness, and that the standard deviations are equal. And as you can see from the figure on the left, while the standard deviations aren't exactly equal, they're close enough so that we can assume, for our purposes of our experiment, that they're equal.
For all null and alternative hypotheses, we tested for any main effects caused by the egg type, whisking, and ingredients. We also tested for the two-way interaction between egg type and whisking and ingredients, egg type and ingredients. And lastly, we also tested for the three-way interaction between egg type, whisking, and ingredients.
For our statistical significance test, we did a 3-way ANOVA because we had 3 explanatory variables that we were manipulating. And from what you can see on the slide here, our only statistically significant variable was whisking at a p-value of 0.006 at a significance level 0.01. Okay, so what we're going to show you next is main effect plots of these variables, which are egg type, whisking, and ingredient. This is our main effects plot for singular variables. And as you can see, the p-value for egg type on the left and ingredient on the right are very high at 0.294 and 0.498 respectively, even though caged eggs do appear to be higher than cage-free eggs, the omelets, and milk appears to perform a little better as well in terms of high omelets. But our whisking was the only significant variable with a p-value of 0.006, and as you can see, whisking does result in higher omelets, so we can reject the null hypothesis that whisking has no effect at an alpha level of 0.01.
And so this is our two-way interaction plot. From this, we can see that there's an overall pattern of whisking resulting in better and taller omelets, except for the case of the water with the cage-free omelet. Cage eggs also seem to rise better with milk than with cage-free eggs.
So for our discussion, we decided that we can reject the null hypothesis that the population mean for whisking is equal because of the p-value 0.006 at a significance level of 0.01. So we conclude that the mean omelette height for whisking was significantly higher than that for no whisking, regardless of the other variables, which were ingredient and egg type. And we also failed to reject all other null hypotheses because the p-values were too high.
Continuing on with our discussion, our lurking variables were egg source, egg size, and whisk consistency. Where our eggs came from could potentially have an effect on our results. And for egg size, since we weren't able to control for the size of the egg when doing our experiment, we see that larger eggs could potentially lead to higher omelets. And lastly, for whisk consistency, since we whisked manually instead of using an electric whisk, all our whisks differed slightly, which could have an effect on our results as well. And for our limitations, we had a small sample size of 3, and also this could be a limited representation of all chicken eggs since we got all our eggs from the same place.
As for our future research, we believe a larger sample size will mitigate the effects of lurking variables considering our sample size is small. An electric whisk would also help give us consistent whisking strengths since ours were manually whisked. And multiple whisking times would help let us see the variations in the effects of different times and help us understand the effect of whisking more clearly. And lastly, the different ingredients would help us see the effect they have and interactions they have with the egg types and the whiskings we have. And lastly, for our references, we use a New York Times article on how to make an omelet, describing very thoroughly the history and art of making omelets, and a Delishably article describing a very thorough recipe for making light and fluffy scrambled eggs. Thank you.